Okay, so as we continue on with our remote learning, what I wanted to do is I wanted to go over some of the types of problems that you're going to see in your packet, and then obviously in your homework. So this is the section after factoring. So with factoring, you have many different types of problems to choose from, or different methods to choose from. You have greatest common factor. Factoring by grouping is when you have 4 terms. Then we have a trinomial where our first term is 1, so it's going to be 1x squared or just x squared, and we're going to factor that way. And then the AC method. So with with those particular ones, the idea behind factoring is we need to find out what x is. So we're going to solve. So the difference between what we were doing with just factoring and what we're doing now is all of a sudden we now have equations, which means we have an equal sign. So the minute we have an equal sign, now all of a sudden we have to figure out what x actually equals. So I'm just taking the page from your math packet and just going to go through several of them so you can see all the different methods of factoring and then how to solve using the factoring method. So one thing before we get into the actual types of problems, just kind of a reminder, is when you have 2 things that you're multiplying together. So if I'm multiplying 2 things together and I have them where they equal 0, well, the idea is either this one has to be 0 or this one has to be 0, because 0 times something is always 0. So this is called the zero factor theorem. So what that means is one of them has to be 0. So for instance, if I had 3 in this value and I had x in that value, what this means is 3 times something has to be 0. Well, if this is 3, that one can't be 0. So that means this one has to be 0. So one of the terms, in other words, one of the terms has to be 0 for it to be set to 0. So with that in mind, when you factor, what you're doing is you're finding terms. Something times something is going to equal 0. So because there's all of a sudden an equal sign, we have to be able to solve and figure out what our x value actually equals. So let me show you the first one. So we have 9x squared minus 16 equals 0. So when you look at this, here's some things that I want you to remind yourself of. We have an equal sign. It is set to 0. Which means I need to find out, what did I multiply together to get this? Well, that's the factoring idea. What did you multiply together to get 9x squared minus 16? So we had those first 4 basic ones, and then we have some special type of factoring techniques. One is when you have a perfect square trinomial, so go back to that video if you need to review that. The other one is when you have the difference of 2 perfect squares. So remember, a perfect square is a number that can be square rooted. So something times something gives you this number. So 3 times 3 gives me 9. This is also a perfect square. 4 times 4 gives me 16. So remember, a perfect square, it has to be the same number that you multiply together to get whatever it is that's sitting in front of you. So with the difference of 2 perfect squares, it's a visual. You need to be able to identify it as the difference of 2 perfect squares. So you're always going to write 2 sets of parentheses. You have to have your equals 0 now. It's not just factoring. Now we're adding one more layer to it. And when you factor the difference of 2 squares, you take the square root of the first one, right? Because 3x times 3x gives me 9x squared. You take the square root of the second one, because 4 times 4 gives me 16. And then I repeat it. 1's plus and 1's minus. And that is factoring the difference of 2 squares. Square root the first one, square root the second one, repeat it, and then 1's plus and 1's minus. It does not matter what order I put the plus and minus in. I can put minus here and plus here, and that doesn't matter. All right, so now we are at the next layer. So now this says this times this will give me 0. Well, one of these has to be 0. So what I'm going to do is I'm going to take each term and I'm going to set it to equal 0. Okay, so I'm deciding, okay, one of these has to be 0. They can be, both of them can be 0. So I'm going to find out what is the x value when they equal 0. So now we are at a two-step equation. I'm going to subtract 4 from both sides. That cancels that. I end up with 3x equals negative 4. And then I'm going to divide both sides by 3. So I get x equals negative 4/3. Okay, so if I have negative 4/3 in here, and I multiply this out and I add 4, I'm going to end up with 0. Okay, now we're going to do the same thing over here. Another two-step equation. This time I'm going to add 4 to both sides. I get 3x equals 4. Divide both sides by 3, and I get x equals 4/3. So, two answers. Why are there two answers? Because this equation is a quadratic equation, right? So if you were to graph it, so remember, this is where we're going with this. If you were to graph this, you would have an x-intercept at negative 4/3 and another x-intercept at positive 4/3. So it would look like this. So 4/3 is 1 1/3, so it's about there. Negative 4/3 is a negative 1 and a little bit more. So I have a parabola. I don't know where anything else happens, but I have a parabola that crosses at negative 4/3 and positive 4/3. Now, we'll get here. This is where we're going to go next after learning how to factor. But we have to know how to factor to get to that. So, you factor, you set each term to 0, and then you solve for x. And that's solving by factoring. All right, let me try another one. I want to try at least one of each technique. Okay, so the next one, we have x squared plus 8x plus 16 equals 9. Now, the reason why we have to set it to 0, we have to make it equal 0, is because that is a really easy way for me to be able to solve for my x's, right? If I said that this term equaled 9, I could have a lot of different combinations. I could have the first term be 1, the second one be 9, the first term be 3, the second one be 3. There's just a lot of different combinations that I can get to be able to multiply together to get 9. So the easiest thing to do is to recreate this equation, rearrange it so that it's set to 0. So what I want to do is I want to get rid of this 9. So I'm going to subtract 9 from both sides. That cancels, so I end up with x squared plus 8x plus 7 equals 0. And where I got the 7 is the 16 minus 9. Okay, so you want to add your like terms. So now we can factor. So this is a trinomial. This is the technique I use. You can use whichever technique you feel most comfortable with. The technique I use is, what do I multiply to get 7 and add to get 8? So I always put my constant term in the top, my middle term in the bottom, and I write my factors of my constant. What do I multiply to get 7? So the only factors are 1 and 7. When I add, I get 8. So 1 plus 7 is 8. So as soon as I know that this set of factors will satisfy when I multiply and when I add, then I can come over here. I always write two sets of parentheses, and these are my factors, x plus 1 and x plus 7. Where do I know it's plus? Because I had to use the positive version of it. Okay, so I factored it. Now I can solve. I set this first term to 0, and I set the second term to 0. So I solve. I'm going to subtract 1 from both sides, so x equals negative 1. To solve, I subtract 7 from both sides. So my two values, my two x-intercepts, is at negative 1 and negative 7. And that's solving by factoring. Okay, so that was a trinomial. So let's try another one. So we have 2x squared plus 5 equals 2 minus 7x. So again, I want it set to 0. So that means anything on the right side, I want to move it over to the left side. So I'm going to subtract 2, and I have 2x squared plus 3, 5 minus 2 is 3, equals negative 7x. I want the 7x over, so I'm going to add 7x. So I have 2x squared plus 7x plus 3 equals 0. So what I did with this 7x is I just put that right in between because I want to write it in descending order. So whenever you're factoring, you have to have your exponents in descending order. 2, 1, down to 0. Okay? So now that I have it set to 0, now I have another trinomial, but this time my trinomial has a number in front, which means I'm going to use the AC method. So again, the technique that I use, AC in the top, B in the bottom. So this middle term always goes in the bottom. In the AC method, when I have a number here, I'm going to multiply these two. That's where the AC comes, A times C. That's where that comes from. So A times C, 2 times 3, is 6. And then I go through the same process. What do I multiply to get 6, add to get 7? So if you aren't sure, just start writing factors of 6. 1 times 6 is 6. 2 times 3 is 6. Which one of these sets, let me write this down here a little more. Which one of these sets of factors do I add together to get 7? Well, 2 plus 3 is 5, so those are out. So the only factors I can use are 1 and 6. Now, here's the difference between factoring a trinomial when there's a 1 in the front and factoring a trinomial with a number other than 1 in front. Is now what I'm doing is I'm changing a trinomial into a 4-term polynomial, and then I can do factoring by grouping. So AC will always take you to factoring by grouping every single time. That's a really important step to remember. So what I'm going to do is I'm going to take this 7x and I'm going to rewrite it as 1x plus 6x. So I haven't changed the value. 1x plus 6x is still 7x, but I've changed from a trinomial, 3-term polynomial, to a 4-term polynomial. And now I can do factoring by grouping. So factoring by grouping, I split it. What's in common between the first two is an x. I use this symbol again. What's in common between 6x and 3 is 3. If you notice, what's in the parentheses is the same. So I end up with 2x plus 1 in one set of parentheses and x plus 3 in the other. Okay, so again, I'm not done because I'm solving by factoring. So once I reset this, now I'm going to come up here and I'm going to set each term to equal 0. So I have 2x plus 1 equals 0 and x plus 3 equals 0. And then I'm going to solve. Two-step equation. I'm going to subtract 1, divide by 2. So x equals a negative 1/2. Here, I'm going to subtract 3 from both sides. So x equals negative 3. So my two values, the x-intercepts, another term for it is zeros of the polynomial because and roots of the polynomial because it anchors to the x-axis is negative 3 and negative 1/2. Okay, let me just do one more. So let's see, let's pick one that, we'll do this one. Okay, so everyone loves fractions. But if you remember, at the beginning of the semester, we went through a whole process in how to eliminate the fraction. So remember, eliminating the fraction means I'm going to find a common denominator. So I'm going to multiply this whole thing by a common denominator. Excuse me. So common denominator is 20. And remember the process is I divide and then I multiply. So I divide. 5 goes into 20 4 times. I write my answer above. 4 goes into 20 5 times. Write my answer above. 10 goes into 20 twice. What I just did is I just eliminated the denominator, and now I can multiply. So 4 times x squared is 4x squared, plus 5 times x is 5x, equals 2 times 3 is 6. Okay? So now I have a trinomial. I want to set it to 0. So I'm going to bring this 6 over as a negative 6. So I have 4x squared plus 5x equals a negative 6 equals 0. I'm sorry, minus a negative 6 equals 0. And all I did is I just subtracted 6 from both sides. I have a number in front other than 1, which means I'm going to use the AC method. So A times C is negative 24. 4 times negative 6 is negative 24. My B value goes in the bottom. And I have to ask myself, what are my factors of negative 24 that when I add, I get 5? So again, if you don't see it right away, just start writing factors of 24. Okay? So now I need to figure out when I multiply these two, I get a negative value, which tells me that one of my numbers has to be negative. Well, since this is a positive down here, I know that all my larger values are going to be positive, which means all of these are going to be negative. So now I can check. Negative 1 plus 24 does not equal 5. Negative 2 plus 12 does not equal 5. Negative 3 plus 8, there are my factors. When I add, I get 5. When I multiply, I get negative 24. Remember, it's got to fit both sets of criteria, both when you multiply and when you add. Okay, so now AC method turns it into a by grouping, which means I have to split this using these two terms. So what's nice about these is I can flip-flop them. I can use them in any order I want. Well, since this has a 4 and 8 has a 4 in common, I'm going to rewrite it as 4x squared plus 8x minus 3x minus 6 equals 0. So the 8 and the 4 have something in common. The 3 and the 6 have something in common. So now I'm going to split it, doing factoring by grouping. So 4x times x, 4x times x is 4x squared. 4x times 2 is 8x. Using this symbol, what's in common between 3 and 6 is 3. What's left, I have x plus 2 equals 0. Again, these two sets of parentheses should always be the same. Okay? So now, one more step in the factoring by grouping. X plus 2 gets pulled off. What's left goes in the other set of parentheses. I'm still having it set to equal 0, and now I'm going to set each term. So I have x plus 2 equals 0, and I have 4x minus 3 equals 0. And then I'm going to solve. So x equals a negative 2. That's one of my terms. Two-step equation. And x equals 3/4. So those are my two x values. Okay? Those are the two roots, zeros of the polynomial, or x-intercepts. All right, the rest of them you should be able to do quite easily. The main thing is to make sure that you have it set to 0. That means there should be a 0 on the right and the factor or the equation on the left, and then you can go from there. And I think that's it.